Multi-step dimensional analysis. If you thought dimensional analysis was fun, wait till you do more steps. Okay, with multi-step dimensional analysis, many problems cannot be solved in one step. Sometimes you need more than one conversion factor to get from your known to your unknown. And that's when this multi-step dimensional analysis comes in. So for instance, how many hours are in 17.0 years? If you just turned 17 and you want to know how many hours you are old, how do you do that? I don't know how many hours are in a year. So I'm going to do this kind of problem in multiple steps. My known is that I start with 17 years, and I want to know how many hours I have. Again, I don't know how many hours are in a year, but I do know there are 365 days in a year, and I do know that there are 24 hours in one day. So I can convert from years to days in one step, and I can convert from days to hours in a second step. So let's see what this looks like. Again, my known is 17.0 years. My hours are my unknown, so that's what I want to find out at the end, and I'm actually going to need to do this across two lines, which is why I wrote it down below. My dimensional lines, when I get to step 2 and draw my dimensional lines, this time I have 2 conversion factors, so I need to have space for 2 conversion factors. For conversion factor number 1, do I want to convert from years to days, or do I want to convert from days to years? I need to make sure I use my conversion factor in the right order. I want to get rid of years, so years are going to go in the bottom and days are going to go up top in my first conversion factor. How about my second conversion factor? 1 day is the same as 24 hours. Should my days be on top or should my days be down below? My days should be down below so that my days cancels out with my days. 1 is the number I write next to day, 24 is the number that I write next to hours. So looking at this, step 4 is going to start to become pretty important here when you have multiple steps. It maybe seemed unnecessary before, but you'll see why it's so important now. Check to make sure your units cancel. Before you do the math, make sure you've got it set up right, otherwise you're doing the math for no reason. The years cancel out, so that's good. The days cancel out, that's good. So I'm left with hours as my units, and that's good because I want hours as my final answer. Let's do the math. I multiply everything that's up top, 17.0 times 365 times 24, and I divide by everything that's down below. So I end up with 148,920 divided by 1. And so the calculator gives me the answer 148,920. But I'm not saying that I'm 17.000 years old. I'm saying, yeah, I'm about 17 years old. 17.0, like I turned 17 this week. So I only know this to 3 significant figures, so I can only report my answer to 3 significant figures, and that's 149,000 hours. Okay. Again, you can, if it helps you, you can do this as 2 entirely separate dimensional analysis problems. I like to do it in one step because I think it's handy to cross out the units like you see here. Years cancels out with years, days cancels out with days. But you can do it as 2 totally separate steps. So I can start with 17 years and go to days as one-dimensional analysis problem, and I can go from days and convert to hours as a totally separate dimensional analysis problem. Each time I'm just going to use one conversion factor, get rid of the years, bring in the days, and I get that I have 6,205 days. Now, normally I would round that off to 6,210 days, but I'm not going to do it yet because I'm still doing more math with that number, and I don't want to round off too soon, because if you round off too soon, you sometimes get rounding errors, and then your final answer is a little bit off. So I'm going to keep that 6,205 days, and use my next conversion factor. Get rid of the days, bring in the hours. And when I do 6,205 times 24, I'm going to end up with 148,920, which is, when I round off to the correct significant figures now, is 149,000 hours. So I wait till the very end to take care of my significant figures. Again, you can also do these kinds of problems using fractions and multiplication signs if you prefer that way. I prefer the train track method, but if you want to do it with multiplication signs, you get rid of the years, you bring in your next conversion factor, you get rid of the days, and you still end up with the same answer no matter how you do it. So there are a few different ways to set up your multi-step dimensional analysis problems. And any of the ways that I've shown you would be correct. In my class, I will generally do both steps in the same problem using the train track method. So it's important for you to be able to look at the examples I'm doing in class and understand where the numbers are coming from. I hope this helped.